This is Intro to Proofs, section 7.1. This is progress check 7.2. So here we have a set T, which is x comma y that are in the real numbers across the real numbers, such that x squared plus y squared equals 64. Okay, so number 1a asks, explain why T is a relationship, relation on the real numbers. Well, it's a subset of the real numbers across the real numbers. That's, you go back to the definition on page 351, all you need to be, a subset. Okay, a subset of the set across itself to be a relation on that set. Okay? Find all the values of x such that x comma 4 is in T. Comma 4 in T. Well, in order for x comma 4 to be in T, you need x squared plus y squared equals 64. So then that means you have x squared plus 16 equals 64, which implies x squared equals 64 minus 16 would be 44, 48. So then 48, that's 3/16. So that means x equals the square root, positive or negative, of 48. That's important, the positive and negative. X equals positive and negative square root of 48. So then we like to simplify that when we can. So 48 factors as 3 times a square, 16. So factor the square out. So positive negative square root of 16 times square root of 3. But then square root of 16 is 4. 4 squared root of 13, which is a much simpler number. So the question is asking find all the values x. These are the values x. All right. What about find all the values x for x comma 9 in T? Not possible. Okay, if you try to solve x squared plus 81 equals 64, then you get x squared equals a negative number, and a real number squared cannot be negative. So not possible. What is the domain of the relation T? So domain, if you look at the definition of the domain of relation, with all the left ones, I'm going to write that down. So the domain is all possible things on the left, and range is all possible things on the right. So what is the domain of this function? Well, what's the smallest number I can get? That's -8. What's the largest number I can get? +8. So the domain, if I use interval notation, because it's clean and simple, it's -8 to +8, including the 8s. What is the range? Now, this function is symmetric, so the range and domain are the same. -8 to +8. Okay? Since T is a relation, its elements can be graphed in the coordinate plane. Describe the graph of the relation. That equation is a circle centered at 0, 0 with radius 4. Or no, radius 8, because it's 64 is 8 squared. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So then draw the circle as best you can. Nah, it's okay. All right, so that's the graph of T. All right, now we're going to do preview activity number 2 from progress check 7.2. And so if A is a set of all states in the United States, and R is this relation that they have a border, explain why R is a relation on A. It's a relation on A because it's a subset of A cross A. All right, what is the domain of the relation? What is the range of the relation? The domain is all 50 states. All 50 states. the range is all 50 states. Well, let's see about that. Some states, like Alaska and Hawaii, don't have any. So the range would be the contiguous 48 states, and the domain would be the contiguous 48 states. Because Alaska and Hawaii, there is no bordered pair. Let's talk about Alaska. So Alaska doesn't border any other states. So AL, comma, doesn't exist. Okay, no matter what state you're trying to put in there, it's not an R. So that means Alaska is not in the domain. So the domain and range would be the 48 contiguous states that all have a border with another state. Same with the range. Okay? And where was I? Are the following statements true or false? Justify your conclusions. For all x and y in A, if x and y are in R, then yx is in R. That's true. Having a border between two states is symmetric. If Ohio borders Michigan, then Michigan borders Ohio. It's a symmetric relationship. Now it's funny, I keep saying relationship and I should say relation. And they mean almost the same thing, but in math, it's just called relation. For all x and y and z in A, if x, y is in R and y, z is in R, then x, z is in R. No, it's not the case. So the state borders is an example of a relation that's not transitive. Okay, I think you'll learn that word. Have you already learned that word? I can't remember it now. Transitive refers to if you know A and B are related and B and C are related, are A and C related? And if yes all the time, it's transitive. All right, that completes progress check 7.2.